Hi everyone, welcome to Mr. Wagid's math class. My class talks about algebra, and algebra focuses on writing and solving equations. So today we're going to talk about the basic concepts and vocabulary that involves equations. The first vocabulary we'll talk about is called terms. In an equation, a term could be a number such as 2/5, -3.8, or an integer 3, or it could be a variable, which is a letter that represents a number, but we don't know what the value of that number is, so we give it a letter such as X, Y, or the letter M. Or term could be a combination of both a letter and a number such as 3t. Now, numbers themselves are in equations. How can we distinguish between a number that stands alone and a number that's attached to a variable? The numbers that stands alone called a constant, such as -16, 2/3, or 5.6. Numbers attached to a variable are called coefficients, such as half x, half is a coefficient, -3.2 is a coefficient, and 32 is a coefficient because it's attached to the variable t. Now, equations and expressions. Equations, you can solve equations, but you can only simplify expressions. The word equation, as you can see, has an equal sign, but expressions, they do not have an equal sign. Okay, now we're going to talk about like terms. What are like terms? We know a term could be a number, a variable, or a combination of both. So when you talk about like terms, it's like combining like items. I can add an apple to an apple, but I can't add an apple to a strawberry. In this case, I'm going to say the number of apples is y. So if I have one y here and 3 apples, you end up with 4y, and I combined the y's. I have 2x, or 2 strawberries here, and I have 3 strawberries here. Now I combined all the strawberries and I have 5 strawberries. A constants are numbers stand alone. 6 and 5 equals 11, and I can combine those two numbers. I combine the y's, I combine the x, and the constants. So let's take this into practice and see how can we simplify this long expression. This expression has 6 terms. You have to combine the x's, combine the y's, and then combine the constant. You have 2x plus x gives you 3x. 3y minus 5y is -2y. Half plus 4 is equal to 4.5. Now that you combined all terms, you can simplify the expression, and you got 3x minus 2y plus 4.5 as a simplest form. Now let's talk about solving equations using inverse operation. For you to understand that, look at the balance scale. And it works exactly the same way as an equation. It has a left side and it has an equal right side, and they have to be in balance or equal. Whatever you do to the left side of the equation, you have to do the same thing to the right side of the equation for it to stay in balance or equal. So if you add something to the left side of the equation, you have to add the same amount to the right side for it to stay in balance or equal. And whatever you take away from one side of the equation, you have to take the same amount from the other side for it to stay in balance or equal. So this balance scale works exactly as the equation. Keep that in mind. Look at this equation. The left side is 2 plus 3 equal the right side, which is 5. It is in balance. The first operation is addition. 3 plus 2 equals 5. But if I subtract 2 from both sides, when that's the inverse of addition, you end up with 3 equals 3. It is in balance. And that's the subtraction property of equality that states if you subtract something from one side of the equation and the left side of the equation, it stays equal. So to undo addition, or the inverse operation of addition, is subtraction. Now what if you subtract 6 minus 2 equals 4? The inverse of subtraction is addition. If you add 2 to both sides, you end up with 6 equals 6. It's in balance. And that is the addition property of equality. If you add something to one side of the equation and the left side of the equation, they're going to stay equal. So to undo addition, subtraction, or the inverse operation of subtraction is addition. Now let's talk about multiplication. 4 times 2 equals 8. The inverse of multiplication is division. So if I divide both sides by 2, I will end up with 4 equals 4. And that is the division property of equality. If I divide one side of the equation with a number, I have to divide the other equation with the same number for it to stay in balance or equal. So the inverse operation of multiplication is division. Now what about division? If you're dividing 8 divided by 2 equals 4. The inverse operation of division is multiplication. Now I'm multiplying both sides by 2. And watch how I use the dot to represent multiplication instead of the x. Now 2 cancels the 2. You end up with 8 equals 8, and that is a balanced equation, which is the multiplication property of equality. That states if you multiply one side by a number and the other side with the same number, you will end up with the same or balanced equation. So the inverse operation of division, or to undo division, you use multiplication. And now how can we undo parentheses? If you have 3 times 2x minus 4, how do I get rid of those parentheses? Something called distributive property. That number 3 need to be multiplied by every term inside the parentheses. So 3 times 2x is 6x, bring the minus down. 3 times 4 equals 12. So to undo parentheses, you use distributive property, which is multiplying the number outside the parentheses with every single term inside the parentheses. Now let's move on to practice some of solving equations on a whiteboard. Okay, now let's solve the equations and check the solution using inverse operation. Remember, the ultimate goal is to isolate the variable to one side of the equation to possibly equal a number. So let's try the first one. G minus 16 equals 8. I need to isolate G. Since we're subtracting 6, to undo subtraction, we use addition. So add 16 to both sides to keep the equation balanced. Now bring the G down. Negative 16 plus 16 is 0, so plus 0. 8 plus 16 equals 24, which gives you G equals 24. That's your solution. Now to check, replace the value 24 with G. Substitute G with 24. So 24 minus 16. And remember, you're checking to see if it equals 8. So 24 minus 16 equals 8. Does equal 8. So it's balanced. It's checked. My solution, G equal 24, is correct. Now the second one, x plus 12 equals 7. To undo addition, you use subtraction. So minus 12 on this side, minus 12 on that side. Bring the x down, and 12 minus 12 is 0. 7 minus 12 is negative 5. So x equal negative 5. That's your solution. To check, substitute the solution, negative 5, instead of x in the equation. So negative 5 plus 12, and remember you are checking, so there is a question mark. Does it equal 7? Negative 5 plus 12 is 7. And it did equal the other side 7, so my solution is correct. Number 3. This is a negative coefficient. There's nothing in between the number and the value, so put a dot, which means multiply. And to undo multiplication, you use division. And I also want to get rid of the negative coefficients, so I divide by negative 4.3, both sides, negative 4.3. Negative divided by negative is positive. 4.3 divided by 4.3 is 1. 1 times G is G. So G equals negative 6. So your solution is negative 6. Check to see. So replace G with negative 6, or substitute G with negative 6. Negative 4.3, put negative 6 in parentheses. Does it equal 25.8? And I put it in parentheses just in case I need to multiply. Negative times a negative is positive, and 4.3 times 6 is 25.8. It did equal 25.8. Checked. Right answer. Now the last one. 6 equal negative W divided by 8. To undo division, you use multiplication. So multiply by 8 and multiply by 8 both sides. But I have a negative that I need to get rid of 2 to isolate the W. So I'm going to multiply by negative 8 on both sides instead of positive 8. And negative times a negative is positive. And 8 divided by 8, make that a fraction to make it as the other one, and 8 divided by 8 is 1. You lift up with W equal negative 48, and that's your answer. Now substitute the answer instead of W to check to see if the equation or the answer is right. So 6, does it equal negative 48 divided by 8? Again, it's a question mark. Negative times a negative is positive, and 48 divided by 8 is 6. So 6 does equal 6. My answer is correct. Now we'll be solving equations that includes fractions. The first one is 3 over 2 equal 9/10. Okay, remember if there's nothing in the middle, put a dot, which means multiply. Now we know if we multiply in the inverse operation is division, but if the coefficient is a fraction, use the reciprocal to get rid of that fraction. And reciprocal is flip that fraction. So multiply by the reciprocal, because any number times its reciprocal equals 1. 9/10, if I multiply it by 10 over 9, and that's the reciprocal, flip the fraction. You have to do the same thing to the other side, 10 over 9. Now multiply across. 9 times 10 is 90, and 10 times 9 is 90. Bring the k down, bring the equal down, and multiply across. 30 divided by 18. Now simplify. 90 divided by 90 is 1. 1 times k is k equals, simplify that, 30 divided by 3 and 18 divided by 3. That gives you 10 over 6. And that's your solution. Now check to see. That means I need to substitute the value of k with the solution. Substitute k with 10/6 and see if it works. So there's a question mark. 3 over 2, does it equal 9/10 times 10 over 6 instead of k? 10 over 6. Let's multiply fractions across and then simplify. 9 times 10 is 90, and 10 times 6 is 60. Does it equal 3 over 2? Simplify that, divide by 30, divide by 30. 90 divided by 30 is 3, and 60 divided by 30 is 2, equals 3 over 2. Checked, it's balanced. Now let's move on to the next one when you're adding a fraction. Now this is a constant, this is a coefficient, because you're multiplying it and it's attached to the variable. We're adding 2/3, which makes it a constant. So the inverse operation to get rid of a fraction if it's a constant is addition or subtraction. Since we're adding, then the inverse operation would be subtraction. So subtract 2/3 on this side, subtract 2/3 on this side. 2/3 minus 2/3 is 0. 0 plus r is r, so bring the r down. Now I need a common denominator. I cannot subtract the way it sits. I multiply by the opposite denominator. So I will multiply this fraction by 3 and this fraction by 8. And whatever you do to the numerator, I have to do to the denominator to keep the fraction equivalent. Now 3 times 3 is 9. 3 times 8 is 24, minus 2 times 8 is 16, and 3 times 8 is 24. Now I have a common denominator, I can subtract. So r equals 9 minus 16 is negative 7 over 24, and that's my solution. Now to check and see, substitute the value of r in the equation, and remember you're checking. So 3 over 8, does it equal, replace r with negative 7 over 24 plus 2/3. Again, I can't add or subtract since I don't have a common denominator. I can make the 3 equals 24 by multiplying it by 8, but I have to do the same thing to the numerator to keep it in balance, or to keep it equivalent fraction. Now, bring the 3/8 down. Does it equal negative 7 over 24 plus 8 times 2 is 16, and 8 times 3 is 24. Now, negative 7 plus 16 is positive 9 over 24. Does it equal 3/8? Simplify now. So divide by 3, divide by 3 both sides. 9 divided by 3 is 3. 24 divided by 3 is 8. Equals 3 over 8. It's balanced, it's checked. The answer is correct. And that's how we deal with the fractions. Thanks for listening. Have a great day.